Hello everyone, welcome to the 8085 assembly language programming sessions. Today we'll learn the instruction add, one of the arithmetic instruction. So it is like add R. So R can be any register. Let us say the description. So this is a 1 byte instruction. It adds the contents of register A with any other register and stores the result in register A. So by default register A will be there in add instruction, and R can be any other register. It can also be A, and the result after addition is stored in register A. All the flags, they are affected according to the result. Like suppose if we write add B, it means A plus B equal to A. Add C means A plus C equal to C. Add D means A plus D equal to D, so on. Let us see some examples. So three instructions are there: MVI A12H, MVI B13H, and add B. With MVI, as we know, that 12H will be stored, 12 it will be stored in A. With MVI B, 13 will be stored in B. And add B, what does this add B instruction? Add B is a 1 byte instruction. It adds the contents of A with B and stores the result in A. So let us run this particular program. So with MVI A, we see that this 12, it gets stored in register A. So in every addition operation, A is always there. MVIB, it will just store the content 13 in register B. And this add B, let us see what add B will get the result. So 12 and 13 we write in hexadecimal notation. Okay, 1 and 2 separately. So 1 is 0001, 0010 is 2, and 13 13001, 0001, 0011. So 0 plus 1 is 1, then see 1 plus 1 is 0, carry 1. 1 plus 0 plus 1 is 1, 0 plus 0 is 0, 1 plus 1 0, and carry 1. And then 1 plus 0 plus 0 is 1, 0 plus 0 is 0, 0 plus 0 is 0. So the result what we get is a 2 5. So 2 5 hexadecimal is our data. This data, the result, it will get stored in register A. Okay, so by default register A is the destination of the addition, and in this operation none of the flags are affected. So sign flag is 0, 0 flag is also 0, auxiliary carry is also 0, parity flag is also 0, and carry flag is also 0. In the next simulation we will see how the flags are affected. Okay. So because the data is all 0 0, so the flag register finally it will contain 0 0 as the output. Now let us see the second example. So in this example we have MVI A78H, MVI D9H, add B, move C, comma A. So first we will store 78 in register A, D9 in register B, add the contents and then store the result. That is, because the result is in A, we store the result in C. Let us see how this will work. So the very first instruction, MVI A, this MVI A will move the content, transfer the content 7 8 in register A. Okay. Then we see the second instruction, that is MVIB. MVIB, of course, this MVIB, it will store the data D9H in register B. So D9 is also a data, and then the contents of the two registers are added. So let us see what we get after addition. So we write first of all 7 8 in hexadecimal notation. 7 is 0 1 1 1, 8 is 1 0 0 0, D is 1 1 0 1, and 9 is 1 0 0 1. So this is how we write D9 and 7 8. Now we do the addition starting from the rightmost bit. 0 plus 1 is 1, then 0 plus 0 is 0, then 0 plus 0 is 0, 1 plus 1 is 0, and a carry 1. So here D3 is passing a bit to D4. So we have a carry on the left, then 1 plus 1 plus 1 is 1 1 1, and then carry 1 on the left digit. So then again 1 plus 1 plus 0 is 0, carry 1. Then next we have 1 plus 1 plus 1, which is 1 1. So we have, this is 1, and this 1 goes here. And finally we have 1 plus 0 plus 1, so it becomes 0, carry 1. Now a carry is generated. So the result is 5-1. Okay? The result is 5-1 after addition. So let us see how the flags are affected. Now, first of all, let's start with the carry flag. Now, because a carry is generated, as you can see, this carry is generated. So this carry will set the carry flag. So whenever leftmost bit generates a carry, that it sets the carry flag. So carry flag is set. Now what about the parity? Now in this result, what we get, there are 3 ones. There are 3 ones in the result. As you can see in the red color, there are 3. Also 3 is an odd number. So the result has odd parity. So because of which the parity flag is reset. So we have a 0 here. Then what about the auxiliary carry? Now auxiliary carry is set if we number these bits starting from the right side. This is suppose D0, D1, D2, D3. So whenever a carry is passed from D0, D3 to D4, so this is D3 and this is D4. So whenever a carry is passed from D3 to D4, if carry is passed, then auxiliary carry is set. Okay, so in this case we get an auxiliary carry which is set and because of this particular bit. Next, what about the 0 flag? Now since the result is not 0, okay, result is actually not 0. So because the result is not 0, so the 0 flag is reset. Okay. So when the result is 0, 0 flag is set, but because the result is not 0, so this becomes 0. And then finally the sign flag. So sign flag is this D7 bit. Okay, this bit is 0. So if this bit is 0, sign flag is also 0. So these are the flag status. Okay, and flag is actually, if we calculate this, 0001 is 1 and 0001 is 1. So this is stored in the flag register, and the final result of addition, that is 5-1, it is stored in A. Okay, the final result what we get is this one. 5-1 gets stored in register A, and 1, this becomes 1-1. Now next instruction, move C comma A. So this result from A, it gets stored in C. It must get stored in C. Okay, so that is the last instruction. So now as we can see, A also contains 51 and C also contains 51. So this is the add instruction. We'll do some more instruction in the coming video. Thanks for watching.